So we're going to divide segments into a ratio. This is a lot like finding the midpoint. When you're finding the midpoint, you're splitting it into an even ratio, a 1-to-1 ratio. When you're, we're just going to kind of take that to the next step, and we can split it into any ratio we want. It could be a 1-to-2 ratio, a 3-to-2 ratio, or whatever ratio we want it to be, 1-to-3. So most of these problems are going to be worded like this. You're going to be given, asked to find the coordinates of P that divides it into a given ratio. So you're going to be given 2 points, A and B. You're going to be told to divide it into a ratio, M to N. So this kind of reminds me of foiling in a way. There is this formula. You could just use this formula. It's no big deal. But within this formula, it's telling you that you need to multiply M, which is the first number in the ratio, to the second point. So that's why you're always going to see an M with x2 and y2. And you're also going to have the N with point A. That's why you see an N in front of x1 and an N in front of y1. You've got the 2 points. M gets multiplied to the second point. N gets multiplied to the first point. And then the number you divide by, rather than midpoint where you always divide by 2, you divide by whatever you get when you add those two pieces together, those two numbers of the ratio. So we are going to be dividing this segment, AB, into a ratio of 3-to-1. So the first thing that you're going to do is 3 plus 1, just put a 4 right there, just so you remember that you're dividing by 4 at the end. Then just like we showed in the formula, you're multiplying the 3 to point B and the 1 to point A. So 1 times point A, we're going to keep the -8 and the -7. 3 times point B, we get 3 times 8, that's 24. 3 times 5 is 15. Now it's kind of like midpoint formula because we're going to add those together. So -8 plus 24 and -7 plus 15. But unlike midpoint formula, we're not dividing by 2, we're dividing by 4. So -8 plus 24 is 16. 16 over 4. And then -7 plus 15 is 8. So that'd be 8 over 4. So you solve that out. 16 over 4 is 4. 8 over 4 is 2. So 4, 2 is the point that would divide that into a 3-to-1 ratio. If you were to plot those, all three of those points, if you were to plot -8, -7, 8, 5, and then put 4, 2 in the middle of them, well, it won't be quite in the middle, you would see the ratio. You would see that A would be over here, B's over here, and then this point that splits it would be somewhere right around there, so that this has a length that's 3 times the length of the other side. It'd be a 3-to-1 ratio. So we could do the same thing with this next problem, a 1-to-2 ratio. So remember, we have to add those for 3. That's going to be our denominator. We're going to divide by 3 at the end. And you also have to multiply. 1 times 2, 1 is 2, 1. And then we're going to multiply the 2 times this point. It's -8, 8. And you add those first numbers, -8 and 2, divide by 3. you add the second numbers, 8 and 1, and also divide by 3. Remember, the 3 is coming from adding 1 plus 2. So negative 6 over 3 is negative 2. 9 over 3 is 3. So there's the point. That divides it into a 1-to-2 ratio. Again, if you were to plot this time I actually will. Negative 4, 4. There's point A. B is 2, 1. And then this point, negative 2, 3, is right there. You can see that if you were to draw that line segment from A to B, that point C is on the line, and it splits it. If you were to find the length from A to this point, we'll call it C, that length would have the ratio of 1 to 2, so it would be 1 to 2. The length of BC will be twice as long as the length of AC. You can also see that with the slope if you just count out the slope. Down 1 over 2. This means the other one needs to go double that. It needs to go down 2 over 4. Down 1 over 2, and then the other one double that. It goes down 2 over 4. Same ratio for the slope, but it's twice as much. It does the slope twice. So same thing, multiply the 5 to B and the 3 to A. So that's negative 18, 15, and 10, negative 15. Now when we're doing this, 5 plus 3 is 8. That's the number that we're dividing by. So you have negative 18 plus 10 over 8. And 15 minus 15 over 8. So negative 8 over 8 is negative 1. And then 0 over 8 is 0. Same question, basically distribute the 3 to this point from negative 18, negative 39. And you're going to multiply the 2 to point A, so you get 8 and 4. We have 8 minus 18 divided by 3 plus 2 is 5. And divide by 5. And then 4 minus 39 divided by 5. So that's negative 10 over 5 and negative 35 over 5. So the point is negative 2, negative 7. So now we're going to look at a very similar question, but it's kind of asking you to do it backwards. Saying, here's the 2 points. Into what ratio does point C divide them? So my suggestion is that you would just plot these points. So to get the ratio, I would plot all the points. Negative 9, 3. And then B is 1, 8. And go ahead and plot C in there also, negative 5, negative 5, positive 5. So if you connect them with a line, they should be collinear. And you pretty much just need to check out the slope. So to get from point A to this point in the middle, we had to go up 2 and over 1, 2, 3, 4. And then to get from point C to point B, we had to go up 3 and over 6, up 3 over 6. So they have the same slope. If you were to reduce this, this would be 1/2 and 1/2. But the question really is, how many times did you go up 1 over 2? So to get from A to C, you had to go up 1 over 2, and then do it again, up 1 over 2. We did that slope 2 times. So from A to C, we did that slope 2 times. And then from C to B, we go up 1 over 2, up 1 over 2, up 1 over 2. We did that slope 3 times. So that's our ratio right there, 2 to 3. You're really just finding the slope and then figuring out how many times you do that slope to get from the first point to the middle and then the middle to the end point. So you do the slope 2 times and then you do the slope 3 times. The ratio is 2 to 3. So I think it's way easier if you graph it, plot them, and then see what it is. So we'll do the same thing here. Plot A, which is 8, negative 5. Then we'll plot point B at 4, 7. So right off the bat, you could just figure out what the slope is from A to B or B to A. The order doesn't really matter. I'm going to start with A. We have to go up 1, 2, 3. Go up 12 and over 4. Now that would reduce. If you go up 12 and over 4, that's reducing to, you could also think of it as down 12 over 4 for the, technically for the slope from B to A. But reduce that, be 3 over 1. So let's put point C in here. Oh, there's a typo here. 8, negative 5, 4, 7. It's not on there. One of these points must be wrong. So this, we'll just say it doesn't work. We'll do the next one. This one doesn't work because point C is not even between B and A. There's a mistake in there somewhere. Because C is not collinear. It's not on the same line as BA. Let's see, hopefully this next one works out right. -1, 2. There's point A. Point B is 7, 14. Ooh, that's going to be off the chart a little bit. That's okay. It'll be 11, 12, 13, 14 up there. So to get from A to B, we're going from 2 to 14. So that means you have to go up 12. And then we're going from -1 over to 7. Which has got a length of 8. Then we have point C, which is at 1, 1, 2, 3, 4, 5. Looks like that's actually on there, so that's good. So we know that the slope to get from A to B is up 12 over 8, which you can reduce to divide by 4, divide by 4, 3 over 2. We just have to look at how many times is that slope done to get from A to C and then from C to B. So to get from A to C, we go up 3 over 2 one time. And then you get from C to B, you go up 3 over 2, up 3 over 2, and then up 3 over 2, 3 times. So the ratio is 1 to 3.